to the channel. Today is July 13th, and we're solving a hard question for the first time, the robot collision. So if you're a regular, I'm sorry I picked up with something else yesterday, so I can only record it right now and post it. So let's look at the question. So there are n1 index robots, so it means the first robot is starting at 1, and then 2, 3, 4 is still starting at 0. And then they each having a position on a line, and then they have health and movement direction. All the other given arrays are zero index, including the positions, health, and directions. So directions I means the I robot is moving in a direction either left or right. So all robots moving simultaneously at the same speed, and then if they collide, the lower half one will be removed, and then the one with greater health will decrease by 1, and then the surviving will continue to move, and then if they're both the same, they both become 0, and then they both remove from the line. Right, so let's look at this example. So this is first robot, and then it's at position 5, as you can see, and then the health is 2. So this is the second robot at position 4, and then with the health 17. And then they're all going to right? This is 0 index, but it means like the first robot's going to right, second robot's going to right, everyone's going to right. So at the end, you want to output in order where the first one is the first robot, and then the second one is the second robot, or the health. If they will run into each other at the end, and no one will be survive, you just return an empty array. All right, just dive into the code. All right, so first of all, I want to know how many robots are there. So I get an n to be the length of the positions. Let me just drag down to this. Okay, and then I'll define indices equals to list of range n, which in this case, if let's say our n is equals to 5, then I will have an indices equals to 0, 1, 2, 3, 4. Right. Another key part is I want to sort the indices in the way that my key sorting is the position of the robot. So after this, if I print out indices, it will be 4, 3, 2, 1, 0. Because as you can see, this is 5, 4, 3, 2, 1, but since this is a 0 index, so you can see this will be 4, 3, 2, 1, 0 in the line. Later on, I will define a result and a stack. Why are we using stack? Is because when we're moving right, and then when we have something moving left, let's say this is moving right, this is moving left, and then when they collide, and then I can pop out the thing from the stack and then compare the health and then decide which one to put it back to the stack. All right. So since we have these indices, we can start with for index in indices, which is we can find the first one that's moving to the right, which is the most left on the number line, right? So if directions of the index is equal to r, and then we want to append it to the stack. So appending the index means we're appending the index of the robot, but it's -1. But we don't care about it because all other things is in 0 indexing. Else, if we're moving to the left, right? So we can say while stack, because if stack has nothing, we don't want to modify this. Let's say if this one, the 3, is moving to the left, and then the health will never change, right? We don't have to put in on the deck, on the stack to modify it. So while stack has something, and the health of the current index is not 0, it's greater than 0. Then we can pop out. You can say the top index is stack.pop. And then since we pop out something, we can now compare. Since there's something we can pull out, right? Let's say this one. So in the case of this example 2, we'll first add robot 3, robot 1, and then 2 is moving to the left. So we now pop out 1 and we compare the health, right? So we can say if the health of the top index is greater than the health of the current index. The top index one, since it's greater half, will minus equals 1. And then the current index will just turn 0. And then we can put the surviving one back to the stack. Otherwise, if the half is less than it, and then we do the current index, half will be minus equals 1. And then the half of top index now becomes 0. And then we want to append the surviving one, which in this case is the index. Lastly, if they're both the same, and then we can just say half of index equals 0, half of top index also equals 0. So lastly, since we are not actually like modify it yet, right? So they actually have the half still signify that there is 0. So if put a half right here, I don't know if I can run it if I didn't return anything. Just return result right now, right? If I run this, invalid syntax, and this is dot sort key equals to lambda. Oh, put an extra colon right here. Oops, looks like I have a lot of typo today. Sorry. Print. Oh. Uh-oh. Right. If I print this, you can see that for case 2 where they will collide, I still have 0 in the half, right? But I want to expect that it's just printing out 14. So in this case, we can go through the index in order for each robot, and then we said if the half of the index is greater than 0, then our result need to append the half of that index. Then in the end, we will return the result because the result is stored. All right, we see this is accepted, and then we can submit it. Oh, that's a wrong answer right here. All right, I spot the difference right here. So when we get the index, when the half of index is greater than the top index, we don't actually append index. We want to go on to the while loop and see if our index is still greater than 0. We want to keep colliding it. So let's say if I'm moving to the left, and then I don't want to append it to the stack because the stack is keeping track everything moving to the right. So when I hit something and then I still have a half, means I'm surviving, I will still going to the left. So I'll still continue to pop up something from the stack to compare. So let's remove this line, run it again, and then try to submit it. All right, now I pass the test. All right, run is 936 milliseconds and a bit 87.18%. The time complexity should be of n log n because we are doing a sorting for the indices right here. Right. I hope you enjoyed the video today, and I'm sorry for the late. And please consider subscribe or like the video if it's helpful. We'll see you all tomorrow.